Hey guys, so we are moving on to our next skill, solving logarithmic and exponential equations. So we got two options here when we're trying to solve log functions. Option number one, if you have log base b of x equals to log base b of y, okay? That means both have the same basis here and they both have log. That means you can just drop the logs and just take x equals to y. So step number one, get only one log on each side. Use the properties of logs to condense. Number two, set the inputs equal to each other. And three, solve. And last one, always check your answer. Number two, if you only have log on one side, there's only log on one side, then you rewrite it as an exponential. Isolate the log. Use the properties of logarithms to condense if necessary. Write in exponential form, solve, and then check your answer as always. So we are going to try to do these first 7 questions over here. Examples 1 to 7. Determine which option to use and then go and solve. Well, number 1 has 2 logs. The bases are exactly the same. So what you want to do is, since the bases are the same, you can drop log base 7 from both sides. That means all you have left is 2x plus 1 equals 3x minus 5. And solve for this regularly. Subtract 3x from both sides. At the same time, you can even subtract 1 from both sides. This will help us solve. Get rid of those, get rid of those. This is now negative x equals negative 6. X will come out to be a positive 6. Now, don't rush to box it up. Remember, the domain of y equals to log of x is going to be all positive numbers, meaning that you can't have 0 in there and you cannot have negative. So you have to go back and check this manually. 6 is x. 2 times 6 is 12 plus 1, 13. That's positive. 3 times 6 is 18 minus 5. That's also a positive. So that's why we can keep the 6. So don't forget to check it really quickly. Number 2, you have 2 logs, but the 3 does not have a log. So you may not drop the log from the first 2 terms. You have to condense that. It will be log base 2. It's an addition, so that becomes 6 times x equals to 3. Can you see that this has 1 log on the left, but no log on the right? So you cannot, again, I'm repeating, you may not drop the log. In this case, you will rewrite it as an exponential. So it becomes 2 to the third equals 6x. 2 to the third will give us 8. 8 equals 6x. Divide both sides by 6. So 8 over 6 equals x. You must reduce. That becomes 4 over 3 equals x. I want you to go back and check. Plug in 4/3. Is that going to give us negative? Since it did not give us a negative answer, therefore we can keep our 4/3. Number 3, log base 12 of x plus 5 equals to log base 12 of 3x plus 31. You have 1 log on each side. You can drop them. You may only drop them if you have 1 log on each side. So now, if you drop the logs, you have these and solve for that regularly. Subtract 3x, minus 5, minus 5. So that will give us negative 2x equals, that will give us a positive 26. Next step, divide both sides by negative 2. X will come out to be negative 13. Don't box it up yet. Check to see if the log is negative or not. When you plug negative 13 plus 5, that's a negative log. You can't keep it. Normally, if there's one of them that's a negative log, that's all you need. But in this case, both of them turn out to be negative logs. So this one, X it out, okay? Do not box it up. Again, X it out. So what happened is you have no real solution. So if log, when you check it and your log becomes negative or 0, then you may not keep that answer. Number 4, you have log on each and every term, but no, you may not drop them. You may only drop if there's one log on the right and one log on the left. On the left side, looks like you have 2 logs and it's an addition. So what you might want to do is condense it. Make it a multiplication of 4 times x. Okay, so now you have one log on the left and one log on the right. You drop them. 4x equals 36. Divide both sides by 4. X comes out to be 39. X comes out to be 9. So check it really quickly. When I plug 9 in, that's definitely not negative, so I can box it up. Number 5, we want to, again, you have 2 logs on the left, no log on the right. So what you want to do is to condense it on the left side. It's an addition problem, so you want to write it as x plus 2 times x minus 4 equals to 2. Then from here, distribute. This will give us x times x is x squared. X times negative 4 is negative 4x plus 2x. 2 times negative 4 is negative 8 equals 2. Make sure we combine like terms. That's x squared minus 2x minus 8 equals 2. Now you have one log on the left, no log on the right at all. You may not drop them because it's not going to be even. So whenever you have one log, you want to rewrite it as an exponential. Your base is 4 raised to the 2 power equal now x squared minus 2x minus 8. 4 squared is now going to give us 16. Then you want to set it equal to 0 and see if you can factor this out. I'm moving it up here. So 0 equals x squared minus 2x. Subtract 16 from both sides. That will give us a negative 24. Let's see if it's factorable. In this case, it is. You have x minus 6 and x plus 4. X minus 6 equals to 0. X plus 4 equals to 0. X equals to 6 and x equals to negative 4. Now take each x value and plug it in. 6 plus 2, first check, positive. 6 minus 4, positive. Let's check the negative 4. Negative 4 plus 2, negative. Negative 4 minus 4, negative. So right now, you have to cross this out. You cannot keep that one. And then you can keep just the x equals to 6. All right, number 6. You have log base 5 of x plus 2 equals to 2 times log base 5 of 10. As you can see, you have one log on each side. But this 2 right here does not have a log, so no, you cannot drop it. So what you want to do is move all the logs to one side. So subtract log base 5 of x to the right, or you can move the 2 log base 5 of 10 to the left. It doesn't matter. So from here, you have 2 equals, this is that's a coefficient. Rewrite it as a power, so that becomes log base 5 of 10 squared minus log base 5 of x. Well, it's a subtraction at log, so we're going to combine a couple of different steps here. 10 squared is 100, so that's going to be log base 5 of 100, but it's a subtraction, so I'm going to write 100 over x, just like that. When you have a subtraction problem, it becomes a division problem. Now you only have one log on the right side and no log on the left. So what we must do is rewrite it as an exponent. Your base is 5. 5 to the second power equals 100 over x. 5 to the second power will give us 25. I can even make it over 1 if I want to, equals to 100 over x. From here, we're going to move over here. We can cross multiply. That's 25x equals to 100. Divide both sides by 25. X will give me 4. Double check. When I plug in 4 in this 1x locations here, is that positive or negative? And that's definitely positive, so you can box this up. Example 7, very similar. Looks like you have log everywhere. So technically you can drop it? No, 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 no. Don't do that, okay? You have to condense it. You may only drop it if you have 1 log on the right and 1 log on the left. So, excuse me. First thing, you have a coefficient of 2 in the front. Rewrite it as log base 6 of 4. Makes the 2 coefficient a power. Excuse me. Same thing with the 1/3 minus log base 6 of 8 to the 1/3 equals log base 6 of x. So now this is going to be log base 6 of 16 minus log base 6. This is 3rd root of 8 equals to log base 6 of x. Well, 3rd root of 8 is really 2, and you have a subtraction here. So we are going to write multiple steps in one. So that's going to give us log base 6 over 16 divided by 2, because 3rd root, let me highlight it, 3rd root of 8 is 2. Then from here, we're going to set this equal to log base 6 of x to the other side. Well, 16 divided by 2 is really log base 6 of 8 equals log base 6 of x. Well, they both have log base 6. So this one's nice and cool. You can drop logs on both sides. So x comes out to be 8. Now let's quickly check it. We only have one location to plug x into, which is that spot right there. And x is 8, which is positive. Therefore, we can keep it. The next part of our lesson today is solving exponential equations. And remember, we solved some of these earlier, but the earlier lessons were the easy type. So option number 1, easy, which we have done before. If you have some base to an x power equals some base to the y power, and the bases are exactly the same, then you drop the bases and you make the exponents equal to each other. So step number 1, isolate the base, get it alone, write each base as a power of the same base, common base. Set the exponents equal and then solve. Step number 2 is more of what you're going to be seeing today. More difficult. If you have a base to an x equals to a, and somehow they are not the same. B and a, obviously, they're not the same. So you can't drop the bases. Instead, use log to solve, okay? So let's try a few of these. 8 to 12. 4 to the x equals 64 to the x minus 5. At this time, you can see that the bases aren't the same, but that doesn't mean that you can't change them to the same base. So 4 is really 2 square, and that's really 2 in x power. 64, that's really 2 to the 6 power to the quantity of x minus 5. And as you know already, power to the power, you will distribute the power. So this is 2 to the 2x, and this will get distributed to both of those. That's 2 to the 6x minus 30. Well, the bases, okay, those two are now exactly the same. So you drop it like you did before and just set the exponents equal to each other. Move the 6x to this side. That will give us a negative 4x equals negative 30. Divide both sides by negative 4, so 30 over 4. Don't forget to reduce, and that will come out to be 15 over 2. So for this one, we have to make sure that you break down the base to prime numbers and then see if we can get it to the same base. Now, on number 9, 4 to the x, technically we can do the same thing, 2 squared to the x. But 24, it's really, I can't really write 2 to anything. That will give me 24. So for this one, we're kind of stuck of trying to write it into a base of 2. Well, even if we try to convert to base of 4, right? Doesn't really matter. We can go, okay, 4 to the x equals 4 to the what gives me 24? Nothing, right? Because it's 4 times 6. It's not to the 4 power 6. So currently, try to put in the same base doesn't work. So what we want to do is we want to use log. You can do this 2 ways, really. You can rewrite it as log, or you can go in and compose log to both sides. So I'm using log base 10 because I don't have a base written. So log of 4 to the x equals log of 24. Well, you have x as an exponent, so x times log of 4 equals log of 24. Divide both sides. Yes, you can divide both sides because remember, log of 4 is just a very, very ugly number. So currently, we have an exact answer of log of 24 divided by log of 4. Now, this is the exact answer. I want us to go find a calculator to see what the decimal approximation is, okay? So we have 24. My calculator tells me I need to type in 24 and then hit the word log. Divided by 4 logs. That means log of 4. So now I have to hit enter. So the decimal approximation is about 2.29. So go back and write 2.29. Okay. So that's if you are composing log to both sides. Now, what if you rewrite it as a log? Yeah, same thing. So base is 4, so log base 4 of 24 equals x. Well, most calculators don't have log base 4, so we have to use the change of base, which is log of 24 divided by log of 4 equals x. Whoa, they are exactly the same thing in the end. So either way, you will get the same answer. Number 10, okay? So we can do either format. We can go in and compose both sides with log. Log of 7 to the n equals log of 20. And it's an exponent. Rewrite it as a product. Divide both sides by log of 7, so n equals log of 20 divided by log of 7. That is the exact answer. Let's use our calculator for an approximation. 20, hit log, divided by, I believe that was 7, hit log, hit enter, 1.54. So that is our approximation. Okay, so I'm looking for both the exact and approximation. Now, what if you go in and use method number 2 by rewrite it as a log? Yep, totally fine. Log base 7 of 20 equals n. Use the change of log, so log of 20 divided by log of 7. This will give us the same exact answer. Woo woo. And then, if you use your calculator, you should get the same approximation of 1.54. So those ones are easy. You can use either method. We have 2 more examples. 11. First, you have to subtract the 3 to the other side. So minus 3, minus 3. So 7 to the x minus 2 equals 56. So now we are going to write it as a log. Log base 7 of 56 equal to x minus 2. As you can see, this can be rewritten as log of 56 divided by log of 7 equal to x minus 2. So I'm out of space. I'm just going to move up here really quickly. I'm going to add 2 to both sides. So log of 56 over 7 plus 2 equals x. Now, technically I can, oops, I forgot the log on the bottom, sorry. Log of 7. Technically, I can box this up and say, okay, well, you know what? This is the exact answer. But isn't 56 something times something that I can be used? Yeah, right? It's 7 times 8, right? So over log of 7. No, you can't cancel out the log 7 right now. But would you agree it's a multiplication here of 7 times 8? So if I want to go further, would you agree I can make it into an addition just like this? Okay, okay. So again, this can extend further. Well, I can rewrite it into this format, wouldn't you agree? Because if you have one common denominator, I can go backwards and break it into 2 fractions just like that. Now I can reduce log of 7 over log 7. So that will give me, sorry, I'm out of space. That will give me 1 plus log 8 divided by log 7 plus 2 equals x. So that will give me 2 and 1, so that's really now 3. So this is really saying, okay, log of 8 divided by log of 7 plus 3 is really my final exact answer. Okay, but if you can get to here, I will also accept that. Now I'm going to try to see if I can use my calculator to punch it in. Okay, so bam, log of 8. Clear it out. 8 log. And then divided by 7 log. Hit enter. And then plus 3, enter. So it looks like I have 4.07. So let's go back. So, oops, I don't need to have a highlighter. X about 4.07. Box that up. Last example, okay? First, you have to isolate your exponential. So I'm going to use a green pen to not invade the other space here. Okay, so minus 2 minus 2. 100 times 3 to the x minus 4 equals 521. Divide both sides by 100. Okay. So 3 to the x minus 4 equals, well, I can't really reduce. I'm going to leave it as the simplest fractions for now. Write it in log form. Log base 3 of 521 over 100 equals to x minus 4. You have a division right now. So we can go log base 3 of 521 minus log base 3 of 100 equals to x minus 4. Then your exact form could be log of 521 divided by log of 3 minus log of 100 over log of 3. At the same time, I'm also going to add 4 over here, and then equals to x. Okay, so looks like this could be my exact answer. Now technically, you can even write the first 2 pieces over one denominator here, log of 3, and then plus 4 equals x. That will also be okay as an exact answer. I'm just going to use my calculator to see if I can find an approximation, okay? So we have log of 521 divided by log of 3. Figure out what I had before. 521 log divided by 3 log. Okay, so all of that in one. And then we had, I think it was a subtraction. Subtract. I'm using this one right here. Okay. Subtract. So right now, okay, so that's about 0.48. So let me write that down so I don't forget. That's 0.48 subtract. Log of 100 divided by log of 3. So clear it out. 100 log divided by 3 log. Enter. 2.84. Oh, you know what? Let me go back and see if I did the first one right, because it doesn't seem like it. Let me try it again. We had 0.48. Okay, that's wrong because I forgot to hit enter. Log 521 divided by log 3. I forgot to hit enter. Okay, try it again. Clear. 521 log divided by 3 log, hit enter, 5.69, that's much better. Okay, 5.69, take away, don't forget to hit enter like what I did, log, divided by 3 log, hit enter, 4.19, 4.19, and then plus 4. So when we comes out to be about 5.44. Okay. There you go. And that concludes our notes.